Hello, my name is Dewa Baskara Pramudia with three last digit name 0 to 3, and here I will explain some of my answer for the assignment. So let's start with number 2. So given a point in R2 and use the matrix multiplication to find the reflection point of the x-axis, the y-axis, and within the line of y equal to x. So for example, we let v is equal to 1 and 3. So to find the x-axis, we use the standard operation. That is by multiplying the v is 1 and 3 here with the standard matrix. So the standard matrix for this reflection is the 1, 0, 0, and minus 1. So we can multiply that with the v, that is 1 and 3. So we got 1 times 1, it is 1, and 0 times 3 is 0. 0 times 1, it is 0, and minus 1 times 3, it is minus 3. So we get the x-axis for the reflection. I'm sorry. So we get the x-axis for the reflection. It is 1 equals 1 and minus 3. And to find the y-axis, it is the same operation as the x-axis. So we can use the standard operation by multiplying the v with the standard matrix. So the standard matrix for finding the y-axis, it is minus 1, 0, 0, and 1. So we can multiply that with the v, it is 1 and 3. So we get minus 1 times 1, it is minus 1. 0 times 3 is 0. 0 times 1, it is 0. And 1 times 3, it is equal to 3. So we get this for the y-axis. It is minus 1 and 3. Next, it is within the line of y equal to x. So it is also the same operation. So we use the standard matrix here. That is 0, 1, 1, 0. And multiply that with the v, that is 1 and 3. So that is 0 times 0 times 1, it is 0. 1 times 3, it is 3. You got here 3. And then 1 times 1 is 1. And then 0 times 3, it is 0. So the result is within the line of y equal to x is 3 and 1. So next it is the number 4. So given a point in R2 and use the matrix multiplication to find the orthogonal projection for the point. So let's use, for example, the point is 2 and 4. So the orthogonal projection for the x-axis, it is by multiplying the v with the standard matrix. So the standard matrix is 1, 0, 0, 0, and we can multiply that with the v, that is 2 and 4. So we get 1 times 2, it is 2. 0 times 4, it is 0. 0 times 2, it is 0. And 0 times 4 is 0. So we get 2 and 0. And then for the y-axis, it is the same. We can multiply the v with the standard matrix. So the standard matrix to find the y-axis, it is 0, 0, and 0, 1. So we can multiply 0 by 2, it's 0. 0 times 4, it is 0. 0 times 2, it is 0. And 1 times 4, it is 4. So we get the y-axis is 0 and 4. So next, it is the question number 8. So here's the answer. So we need a point in R3. So given the point is 2, 4, and 6. So A, contraction with the factor of k, it is less than 1. So we can multiply the point with the standard matrix, and with the factor of k, it is, because it's less than 1, so we, for example, we use 1, 4. So we can use the standard matrix. It is the standard matrix form. So we can replace the k with 1, 4. We get this form of standard matrix. We can multiply this with the point, that is 2, 4, and 6. So we get this 1, 4 times 2, it is 1.5. And because the order 1, 0 times 4, and 0 times 6, it is 0. So we get the result for the x is 1/2. So for the y, so because the other one is equal to 0, so we can multiply the 1/4 times 4, it is 1. So we got 1 here. And then here for z, we can multiply the 0 times 2, 0 times 4, it is equal to 0. And then 1/4 times 6, it is 6/4. So that is the result of the contraction for the point. It's 1/2, 1, and 0/4. And the dilation with the factor of k is more than 1. So because the factor of k is more than 1, we can use, for example, factor of k is equal to 3. So multiply the point with the standard matrix. So here's the standard matrix form. You can just replace the k with 3. So by doing that, we get this form, is standard matrix, and then we can multiply that with the point that is 2, 4, and 6. So so 3 times 2, it is equal to 6, because the other one is equal to 0, you can just ignore that. So we get the 6 for the y, then 3 times 4 is 12, and then 3 times 6, it is 18. So because the other one is 0, so here's the answer for the dilation. Next is the expansion of x-axis and factor of k is more than 1. So for example, we use the factor k is equal to 2, we can multiply the point with the standard matrix. So because we must find the expansion in the direction of x-axis, so we use the factor k on the x here. So the other one will be 1. So we can replace the k with 2. So here's the standard matrix. And then we can multiply that with our point. There's 2, 4, and 6. So here is the multiplication. So 2 times 2, it is 4. 1 times 4, it is 4. And 1 times 6 is 6. And the other one is 0. So because the other one is 0 on the result, so here is the expansion result is 4, 4, and 6. And last one is compression in the direction of y-axis, and the factor of k, it is less than 1. So because the factor k is less than 1, we can use, for example, k factor is 1/4. So we need to multiply the point with the standard matrix, and because we need to find the y-axis, so we can use the k on the y. Same as before, the other one will be 1. So we can replace the k with 1/4. Here's the standard matrix, and multiply that with our point. So it is 1 times 2, it is equal to 2. 1/4 times 4, it is 1. And then 1 times 6, it is 6 here. So we get the compression result is 2, 1, and 6. So that is all for my explanation, and thank you for watching this video. Have a great day.